Okay, so as mentioned, one of the lingering huge questions in chemistry in the early 1800s was where are these chemical elements? If the four element theory was incorrect or at least insufficient, and the world was indeed made up of many chemical elements, where are these chemical elements? As mentioned, the suspicion was they're locked up in ores, in minerals, like what we now call copper sulfate. Of course, at the time, this mineral was not called copper sulfate. But obviously, on the earth, in the crust of the earth, there are tons and tons of ores and minerals and rocks. What types of elements may be lurking or locked up in these things? So let's do our best to utilize this new tool in chemistry called electricity, and harness the power of electricity to break apart ores or minerals. And so here, of course, we're going to try to break apart the mineral copper sulfate. And again, about 1 spoonful should be sufficient. You don't have to weigh it out, but I'll just give a little weight. So I have 8 grams here, 7 grams, 8 grams is fine. Just pour it into any cup, Dixie cup, plastic cup, glass cup. I will put the lid on my copper sulfate and about 50 milliliters of water. I have a beaker here full of about 200, so I'll pour in about 1/4 of this. Yep. Okay. And then copper sulfate dissolves in water, as we already know. So take your time to mix it. It might take a while. So I'll go ahead and do this and be back in a moment. Okay, that actually took about 2 or 3 minutes to mix. The more vigorously you mix, the quicker you can dissolve the crystals. Another way to make it quicker is to use less copper sulfate. That'll be a quicker way to dissolve the copper sulfate. And mine's not perfectly 100% dissolved. You can still maybe see some copper sulfate crystals at the bottom of this solution. But I think the solution is concentrated enough with copper sulfate that we should be able to see some results. So let me go ahead and set up the experiment. So take 2 pieces of pencil lead, and it's actually not lead, of course, it's graphite, which is pure carbon. These will serve as our electrodes, and interestingly, graphite is very conductive, electrically conductive. So I'm going to take 1 9-volt battery. I'm going to hook 1 alligator clip to 1 pencil lead. I'm going to hook this lead sunk into the copper sulfate. So let me connect this second alligator clip to the other piece of graphite, pencil lead. And you don't want the 2 pieces of lead to touch. That'll short circuit. And connect one to the positive side of the battery and the other to the negative side of the battery. And this takes a little bit of dexterity. You want them both submerged into the copper sulfate, and I'm holding one. The other one seems to be stable. So once you have your setup and your experiment running, of course, take some observations just immediately, and I'll report more details in the landing video. But immediately I can tell you the graphite connected to the positive terminal of the battery is producing all kinds of bubbles and actually giving off some like brown flakes. I imagine that's the carbon that's kind of getting chewed up. But of course, I'll report back to you our details and results in the landing video. And yeah, again, make sure you kind of keep track of the time. Run it for about 4 to 5 minutes, and I'll see you soon.